All right, everyone, welcome to another video. We're going to be talking about variables and arithmetics in this, but overall, we're going to be focusing on talking about the IPO model and going through an example problem with you together. So let's learn through a problem. So in this example scenario, you as a programmer have been tasked with creating a temperature converter. So the program is to receive a temperature in Fahrenheit. The program's job is to convert it to Celsius, then display the answer. This will be done in the Python language, and your boss just wants to see a text-based prototype before they work with it more in the future. So to start off any programming questions like so, what I want you to do is something of a problem analysis. Really just asking a bunch of questions that you might want an answer for from your employer or whoever you're working for. So for a question like this, these are some of the questions. This is not a full list of questions, but these are some of the questions that we can ask. For example, what would the temperatures be like? Would it be written in numbers or written out in words? What happens if user makes a mistake? Right? So those are some stuff that we need to handle and code if we wanted to way later in the future. Right? Is there an upper limit? Is there a lower limit? When is it too hot or too cold, let's say? Could this program require voice recognition? And how do we program that or implement that into our program? If this was a full-fledged app, like what would the logo look? Would it be a mobile app? Should it work on Android and iOS? Should it be a web app? As in, like, should it be a web application? Should it be a Windows app? Should it be a Mac OS app? So there are whole bunch of different scenarios that we have to consider when we create a full-fledged program. And lastly, well, should the program be able to work the other way, like calculate Celsius to Fahrenheit, or even consider different temperature units such as Kelvin? However, for this one, we're going to be just doing a bare bones solution first. Then maybe later on, you can take this program and improve it as you increase your programming skill. And we're going to solve a bare bone minimal version of this problem by using the IPO model. The IPO model is a process where any simplistic problems can be molded into the model to help us solve problems. And each represents the three stages of a solution for a problem, I being the input, P being processing, and O being output. The input considers the requirement of the problem from the environment or the user. And let's talk about a laundry machine. Right? On the laundry machine will take inputs of articles of clothing or items to be washed. It can take water, cleaning detergent, coins for payment, power washing setting types, and a timer, right? How long do you want to wash it for, right? So when we formulate these kind of requirements, we think about, okay, so we need to handle these data values, and how do we use that in our processing to output correct result. Then we go into the processing. When we get all the data, or we're given the proper inputs, what we want to do is process it properly. A laundry machine should wash the clothes, not dry it, or do something else with the clothes, right? So the processing component considers how the solution is handled or handles the given input. So for a laundry machine, when given proper inputs, the machine will be required to add a certain amount of water and spin a certain amount of time based on our inputs prior. The machine can also create change or ask for more payment based on the monetary inputs as well. So it can be very complex in terms of what kind of laundry machine it is. Then in the output, when we design an IPO model, I want you to think about the expected output, right? So if I did X, Y, and Z, what is expected? And if your processing didn't output the expected output, we know that there are some errors and problems that we need to fix with our program. Okay. So for a laundry machine, it is expected that all the wash items are clean. However, in real life, that's not always the case, right? Sometimes certain clothes are more washed than the other. Sometimes your socks disappear out of nowhere. Okay. So what we want to do is we want to create the best list of expected output for a certain scenario so that we can test our program so that our program runs smoothly 100% of the time. So for our lesson problem, our input would be a temperature in Fahrenheit. The program should receive it as either an integer or decimal. To process that, there is a formula to convert Fahrenheit to Celsius. So if we set if C represents Celsius and if F represents Fahrenheit, the formula is C is equal to altogether F minus 32. and that multiplied by 5/9. The output would be a text and number displayed on screen, which will be on our console over here. And we're going to convert the Fahrenheit temperature to Celsius, and let's translate that over. So in our first line of code, we're going to just write a comment. We're going to say this is a Fahrenheit converter made by whatever your author name would be. Today's date is 04/7/2020. Purpose: use the IPO model to solve this problem. Okay, so let's deal with that input. We're going to take temperature in Fahrenheit. So we need a variable to hold that input, so let's just call that Fahrenheit. Set it to an input of enter the temperature in Fahrenheit, and a little colon space at the end. And let's make that a, you can use float or integer here. Right now, let's not worry about that, but just for kicks and giggles, let's use a floating point. So what I'm doing is I grab an input and I'm converting it to a floating point so that it's a numeric data type that we can manipulate. And that's what we need for input. Let's go to processing. I'm interested in Celsius, where we're converting the value of Fahrenheit. So we're going to go Celsius. I want to hold the result of our formula into Celsius. So we're going to say Celsius is equal to altogether Fahrenheit multiplied by, I subtracted by 32. Then we're going to multiply. It's not the X, but it's the asterisk. And just for case, I'm going to do 5/9 in brackets as well. So right now I have a variable called Celsius, which is going to hold the result of this operation. So Celsius variable is assigned to this value. And output, we're going to print Fahrenheit, comma, to separate multiple items in a print statement. In Fahrenheit is, let's use a new line, prints Celsius in Celsius degrees. Okay, so let's test this program. So it's going to ask us, enter the temperature in Fahrenheit. If you notice, that message is inside our input statement. Enter the temperature in Fahrenheit. So inside the input function here, we're not giving a value to Fahrenheit. We're given instruction that should be displayed on the console. We're actually, when we type a value like 100, now after I press enter in the console with this value of 100, that value is now assigned to Fahrenheit. First, it'll be a string because input always grabs data as string. Then we're going to convert it to a floating point. So it'll be 100.0. And if I press enter there, it will now output this section, line 13 and 14. Before we get there, all this will be initialized and processed first, then does line 13, then does line 14. So if you notice, 100.0 instead of 100 we inputted, because it's a floating point value in Fahrenheit, is 37.77777778 in Celsius degrees. And that would be our program. Okay. So if you notice, when we have our input, processing, and output all laid out, it is very simple just to translate each section over so that our program can execute our code from top to bottom to handle the input into our processing, and we can calculate all that and put it to our output. This is why we use the IPO model to solve basic problems. Thank you for watching. Stay classy.